the second installment of Emnify's IoT Talk. My name's Jakub Boote. I'm a product marketing manager here at Emnify. And today we're going to talk about the future of IoT eSIMs. We're going to clear up any confusion around the SIM and naming conventions, and we're going to discuss SPG32, which is a GSMA standard to enable a whole new world of functionality for remote SIM management for IoT devices. Today, I'm joined by two of our very own product managers, Mario and Christian. Maybe you guys would like to start by giving us a short introduction.
Okay, I will start. It's Mario here. I am the head of SIM and logistics here in Emnify. I joined the company 4 years ago. And before, I've been working for almost 20 years in Italy in mobile operators there. So I'm responsible mainly for all the technical and the logistics topics for the SIM here in the company. Christian.
Yeah, my name is Christian Henke, and I'm the director of product management for our product portfolio. And SIM is at my heart, so really looking forward to the discussion here and to share some expertise.
Excellent. Thank you very much. So I think I'll jump straight in with my questions. And my first question is, I mentioned in the introduction there is still some confusion around the different naming conventions for eSIMs. Maybe Mario, you can kick us off by clearing up any of that confusion and letting us know the difference between the different form factors.
Yes, let's try to make it a little bit clear. But I mean, first thing to do is that the expert in telco business are the main responsible of this confusion. Okay, over the years. But anyway, we have a main distinction between the SIM form factor, that is the actual format, physical format of the SIM on one side, and on the other side we have the technology that any kind of this form factor can embed. So when we are talking about form factor, we are talking about the pluggable SIM that can be removed from the device. So the mini SIM, or also known as 2FF, the micro, the nano SIM, or the multi-cut form factor that you can buy and you can unplug the specific form factor that you want. And then on the other side, we have the soldered modules, the SIM that must be soldered directly on the board of the device, okay? And these are so-called MFF2, that is mobile machine form factor number 2 or number 1. This is the form factor, okay? So the physical format of any SIM. On the other side, we have technology, okay? This SIM, whatever is the form factor, can embed. So we have the standard SIM, the very old standard SIM that are not embedding any kind of technology. We can call them simply SIM. Then we have what is called eSIM or EUICC, okay? That are the SIM. Again, no matter the form factor, that can embed different type of eSIM technology, that is this capability to be provisioned over the air with a specific subscription, okay, with a specific tariff plan. This eSIM can be currently of 3 different types. The oldest one, that is the so-called machine-to-machine UICC, the very first standard being defined by GSMA to provide this kind of remote management of subscriptions on the SIM. Then we have the consumer eSIM, okay, the one that we have on a lot of smartphones right now. So you can just scan a QR code, or you can download any SIM via your carrier app, etc. And finally, we have a new standard, so a new technology that is called the IoT eSIM. That is the new standard being defined by GSMA, released last year, the first version, this year, second version, and is related to, it's a kind of mix between the first and second standard, but we will explain a little more later, okay? So this is the main difference. Okay. Form factor and technology. Any form factor can use or can embed any of those technology. Even if, for example, when we are talking about eSIM for consumer eSIM, and so smartphone, etc., typically they are using an embedded, a soldered module. So these are MFF2 or other format that are embedded, not removable.
Okay, thank you very much. And one of the first questions that comes to my mind then when you talk about the different types of SIMs is everybody's familiar with the eSIM that they have in their iPhone. Why is it that this eSIM is not typically used in IoT devices? What is the difference there?
Yeah, it's a good question, Jacob. Like, it feels so easy when you have an iPhone to change. I mean, there's challenges as well, but in general, it feels so easy. And the question is, why doesn't it work for M2M eSIM the same way? And the first thing is that on the consumer eSIM, yeah, you have a camera and you have a user intent. So there's someone that kind of pulls the SIM card profile to the device. With an IoT device that is remotely deployed, this is not possible. There's no user that clicks on the device and then pulls the profile to the device. And most of the devices, they also don't have this interface, a camera or a user interface that allows the download of as a profile. So the M2M eSIMs that were intended for these machine-to-machine type communication is actually able to push eSIMs to a device without someone being there. And that is the standard which is required when you don't need or want a user interaction.
Okay, and you said this M2M eSIM, it was brought out to address this need for a camera that we have for consumer eSIM. Was it completely successful for doing that? And what are some of the other advantages and disadvantages of the M2M eSIM?
So M2M eSIM has like a mixed success, right? So in general, the M2M eSIM is great if you want to future-proof your SIM card, if you want to be sure that you can update your SIM card with new technology that is coming out, because it's easy updatable over the year. Now, kind of what has been promised by the standard, that it's easy to change service provider from one provider to the other. This is really where the M2M eSIM has a drawback. And that is based on the infrastructure that is needed to run such an M2M eSIM. So these infrastructures are called remote SIM provisioning platforms, and the technologies, the SMDPs, SMRSR. And the setup is not only costly for these infrastructures, but also the integration is needed to actually move SIMs from one service provider to the other. And these integrations are typically very costly and kind of not economically viable for IoT solution providers. And that's why we seldomly see in the market where really an enterprise changes from one service provider to the other. There are some offerings in the market where M2M eSIM profiles are used, and also switching is happening. But typically, these eSIM profiles, then you stay still with one connectivity provider. It's just changing you from one profile to another, but without really changing the one that you are kind of built to. And the drawback of these M2M eSIM is also that kind of you end up on a different core network and with different functionality. So there are other alternatives like multi-IMSI that would be a cleaner approach to changing different profiles while maintaining the APIs. And another drawback of M2M eSIM, which is also addressed with the IoT eSIM, is that it needs SMS. So any device that is not SMS capable, so the narrowband IoT devices, would not be able to be updated with the M2M eSIM.
Mario, the third type of SIM you mentioned is the IoT eSIM, also referred to via SPG32. What is this and how does it address some of the problems we've already talked about?
The standard is very promising because it solves all the problem and issues that were coming from the UICC, the M2M UICC. So firstly, you do not need any more integration between different systems to have the possibility to download a different profile, a different subscription from a different operator. Then you do not need any more the SMS. Okay, so this means that you can also address specific device, for example, NB-IoT. You can rely on the HTTPS, so meaning that you can adopt this technology even if you are deploying LPWAN devices, so low battery consumption devices. This is a huge advantage that the old technology is not able to cover. This is the best things that should come and will come from from the new standard, from the SPG32.
Okay, thank you very much. And Christian, that sounds great. Almost maybe too good to be true. Is there a catch or a potential challenge that we should be aware of with IoT eSIM?
Yeah, you make the right question, right? So every new technology may have a catch, and there's a hook. And so first of all, the technology is not available yet. So it's the right time to talk about IoT eSIM because the standards are, ready, or some of the standards are already available since last year, but some are still ongoing. And it's really the right time to talk about it. But also already based on the standards, it's visible that there are some challenges that will come with the IoT eSIM, which have also be, let's say, a challenge when you were talking about the M2M eSIM. And one thing which needs to be very clear is that whenever you do a profile switch to a different provider, in fact, you are changing the core network. Yeah, so you will have potentially different functionality available from your connectivity provider that you're switching to. But that might be, negligible. But if you think about it more closely, you will also have changes in the API. So you need to integrate the different APIs. Your VPN setup will change. Your IP addresses that you need to address your devices. And last but not least, also your MSISDN number, your phone number to reach the devices via SMS, for example. And like in the consumer side, that's one of the challenges that you have. You still have to transport your MSISDN number to your new contract so that you're still reachable for your friends and family. Same as somehow with your device, you don't want to change and let everyone know that you have a different SMS, a different number for your SMS. But on the IoT side, if you change the provider, which is originating from a different country, then there is not yet any portability across countries. So that makes the changing still challenging. And I'm really looking forward to the standard to see how it looks in practice. And we are working on it to early test and validate with customers on, what other shortcomings there might be or how to overcome those.
And when is it you think this technology is going to be ready for the market? Maybe Mario, you can take that question.
Yes, we still need 1 year, at least 1 year to have the first deployment for technology itself, the offering from the service provider, from telcos, and also for devices. Okay, because it's not only a matter of the backend to be ready, to be developed, tested, and to be ready, but also the devices, the IT devices. And the reason being that typically the GSMA is releasing the standard itself, so the technical specification related to technology. But then the GSMA goes through the definition of the testing that must be done by OEMs, so by devices, by the SIM, and in this case by also part of the backend in order to be compliant with this specification. So everything must be tested against specification that GSMA is releasing right now. So this will take time, okay? The full testing of devices, of the SIM, etc., will take 1 year, not less. Okay, so we can imagine that we will have, by the end of first half of next year, the first commercial deployments of technology and related services. Okay.
Yeah, and you mentioned devices a lot there. Why are the devices so significant? Does the IoT eSIM need to be supported by the device itself?
Yes, I mean, we were telling before that the standards is related to new the IoT devices that miss, for example, capabilities. So on device, we do not have anymore the screen, we do not have the camera, we do not have an user interface, we do not have specific protocol idea, for example, IP connectivity, etc., for this low power device, etc. So the new standards, okay, is moving outside of the device a specific part of the logic. Okay, and this there is a new application that is called this new part of the application that is called eIM, that is URCC profile manager, that it's outside of the device, and it's acting as the application that can download the profile, the subscription to the device. This part has to be certified. Then we have another new software that is running either on the SIM or on device. This part of the software is called IPA. Okay, and this IPA can be developed on the UICC or on device. Now, it's hard to guess right now what will be the main solution. Most likely, the main development will be main adoption on device, exactly like it's now for the smartphones. Okay, could be that device will have to be integrated with this API, this specific. This is why also device must support in such a way the new standard, because they need an application, a specific application.
Yeah. Okay, and moving on then. So another form factor we talked about in the introduction, but we haven't really touched on so far, is eSIM. Mm-hmm. And I think maybe this adds to a little bit of confusion around the naming conventions as well. Can you tell us a bit about eSIM and how it relates to the other form factors?
Yes, eSIM stands for integrated SIM. Okay, now it's not an autonomous, a kind of specific autonomous form factor. It's just a way to move the SIM, okay, within the microprocessor or device. Okay, so instead of having a removable SIM or an autonomous module soldered into the motherboard of the device, we have the SIM that is a part of the so-called SoC, system of chip. Okay, and so it's a specific area of the microprocessor. Now, so far, we have specific modules, specific microprocessors that are already supporting this new form factor. Okay, but it's a pure standard SIM. Okay, it's without any UICC, any eSIM capabilities, meaning that if you want to adopt a radio module, a device that is supporting the integrated SIM, you have to go through a very long, elaborated process to buy these modules. And then you have this integrated SIM that is part of the SoC. You have the subscription data of your preferred operator within, but there is no way, no possibility to change. Okay, you have to change the device. Then at the second stage, when also the new SPG32 will be finally available, then the integrated SIM will make more sense, because you will have the possibility to provision the connectivity in factory stage, so when the device is being produced, and right after, when the device is on the field, then device supporting and the SPG32 can be updated with different connectivity, with different profiles. Okay, but so far it's just a different way to store the SIM.
Okay, thank you very much. And a question for you, Christian. I heard the term soft SIM quite a lot. Can you tell us a little bit about what that means?
I mean, the integrated SIM is kind of like a soft SIM. Yeah? So it's a SIM that is kind of software based, which you then kind of upload on the hardware itself. But what we see in the market are there, kind of proprietary implementation of, releasing kind of the software or the SIM as a software, which is kind of troublesome because you don't have any standard for it. So that's why we are after the integrated SIM standard, because there we're sure it's interoperable, and it really, whenever the customer decides to move away or wants to use that technology, they really have a different option, someone else that is offering the integrated SIM, and don't need to rely on any proprietary solution and be stuck with the vendor.
Yeah. Okay, well, that wraps up our questions for today. Hopefully we've cleared up any questions people have regarding the different SIM form factors and SPG32 and its implications on IoT connectivity for the future. Thank you very much, Mario and Christian.
You're
and
welcome.
If any of the audience have any follow-up questions, just visit emnify.com and fill out the contact request form, and somebody will be in touch with further information.